Hi, this is Andrew. Thanks for joining me. This video is about DHCPv4, which is assigning IP addresses automatically to clients using IPv4. So DHCP is Dynamic Host Configuration Protocol, and we will see basically the basics of how it works. We will see how to configure it, and we're going to be using lab 742 from Network Academy, which covers a few other things, and I'll cover that as well, most of the pieces of that. So if you want to skip ahead to certain parts, look at the description. I'll have sections for the configuration, general configuration, subnetting, and the whole process. So let's look at the lab so you understand the subnetting portion of it. What we have here is the lab itself, and if you notice, there are some empty addresses here. So first step, let's look at the scenario. Dynamic Host Configuration Protocol describes the whole process. So this is actually a hands-on lab. I'm going to do it in Packet Tracer just because it's a little bit easier to visualize when you can see everything right there. If you think it would be helpful to see it with real hardware, I do have real hardware. Let me know and I can create a video showing some of the basics with real hardware. Step 1, establish an addressing scheme. We're going to subnet 192.168.1.0/24 to meet the following requirements. We have 3 subnets we need. We need one that supports 58 hosts, one that supports 28 hosts, and one that supports 12 hosts. So that's going to be step 1. Let's dive in and do that right now. Okay, so now what we need to do is variable length subnet the 192.168.1.0 network. So I always like to start with values of the binary conversion. So 128, 64, 32, 16, 8, 4, 2, 1. So this is what we're starting with. Now we have a situation where we need subnet A has to have 58 hosts. Subnet B needs 28 hosts, and subnet C needs 12 hosts. So I'm actually going to create a chart down here that I will fill in, and we will use it in a little bit. So subnet A, let's go subnet B, and then subnet C. So we have 3 subnets here. And let's just, after each one, put in how many are required, even though these are not the numbers we're going to have. But we'll just put it here so we can make sure that we at least exceed those requirements. And 12. Now, we don't need to worry about any of the other details that are in the directions right now, so let's get them out of the way. We are working with this scenario. We have these subnets, and we need to know what subnet mask we'll use for each subnet, and then what are the range of IP addresses going to be. Now these are all going to be part of the 192. Let's not be in there. 192.168.1.0/24. So we're going to have a network address in each of these. Will have a first and last IP address. First and last usable, we'll say. So first step, 58. Now if we use the magic number process, and let me know if you need more assistance with variable length subnet masking. It's something that a lot of people really get hung up on. But using the magic number, we know we need a 1 in that part of the, in that bit for the subnet mask. We need a 1 there, and then we need zeros in the rest. So this is our subnet mask that will get us 64 addresses, technically 62 addresses, because we can't use the network or the broadcast. So this is the first one we're going to use, and if we look at it as /24, we add 2 bits to that, we're at /26, also known as 255, 255, 255, dot 192. It's 128 plus 64. So that's the other way to put this subnet mask in there. But I'm going to put it in as 192.168.1.0/26. Those are the two more bits, and that means that the range of usable IP addresses, the first usable IP address is 1 above the network, which is 1. Using magic number, then the next network would start at 64. So the broadcast address is 63. So the last usable address is 62. So now we're going to start at 192.168.1.64. The question is, how far do we go with that? We need 28 addresses. So we're going to change that 32, the 0 there, to a 1. Now we have a /27, and that gets us 32 usable addresses. So we have a /27. Let's figure out what the next network is going to be. That's going to make it a little easier to figure out the range of addresses. So the next 192.168.1. If we take 64 and add 32 to that, we get 96. Now we don't know what the subnet mask will be on that network. We're not going to worry about that yet, but we do know that our range of addresses is 65 all the way up to 95. Actually, 95 is a broadcast, 94. Now, we need 12 addresses there. Now, that will get us 12 addresses by putting a 1 there. That is one more address, 28. And even though we don't have a subnet D, we're going to figure out what the next one is anyway. 192.168.1. If we add 16 to 96, that is 106.112 would be the next network. So that means here we have 97 to, not 111 because that's broadcast, 110. There's our variable length subnet mask. Okay, I'm going to now look at the directions here that tell us what we're going to do. We have directions of the subnet A, 58 hosts. We have 62 hosts, so that works. So we're going to record the first IP address in the addressing table for gigabit for R1 G, and I'll put it down here right now so we can follow along with it, .100. And that first IP address is 192.168.1.1. Now we also need a subnet mask, and it's a /26, which is 255.255.255. Remember, 26 is 128 plus 64, which is 192. There we go. Now, record the second IP address in the address table for switch 1 VLAN 200, and that is going to be 192.168.1.2. Let's make that a little bit better, and 255.255.255.192, and then its default gateway is going to be 192.168.1.1. So that is for subnet A. Now subnet B is going to be record the first IP address for R1 G001.200.200, and that's going to be the first IP address of subnet B. 192.168.1 dot right here, subnet B 65 is our first IP address. 65 and 255.255.255 dot. It's a /27 network, which is 192. It's 128 plus 164 plus 32. 192 plus 32 is 224. And then we have record the second IP address for S1 VLAN 1. S1 VLAN 1 is 192.168.1. The first one is 65, the second one is 66. 255, 255, 255, 224, and of course default gateway 192.168.1.65. Of subnet C, 12 hosts, that is the client network at R2. Record the first IP address in the addressing table for, oh, it's a period at the end of the sentence. I was looking at it as sub interface. Okay, so R2 is G001, IP address 192.168.1. First IP address 97 right there. And that's all we need. Well, we still need 255 dot. This is a /28. So 128 plus 64 plus 32 plus 16. It's also 224 plus 16. 240. So we've just variable length subnetted according to their requirements. We created 3 subnets with different subnet masks depending on the number of networks that are needed. Now in this diagram, they could have all been the same subnet mask. They could have all been /26s because we only needed 3 networks. As a result, we have more IP addresses left for future use. That's why they wanted us to subnet mask variably, but there we go. And so I'm going to take these addresses, put them into the table, and then we can move on to the next part, the basic configuration. Okay, I filled in the chart that had all of the addresses and discovered there was an error in the lab that really more of a typo. In step 1, subnet A, which we created, it says record the IP address in the address table for the router. We did that correctly. But when they talk about address for switch 1 VLAN 200, that really should have been from subnet B. And if you look at it down here, switch 1 VLAN 200, that is from subnet B. That's the second address from subnet B. The first one is from the interface here. And that makes a lot more sense. If VLAN 200 is on subinterface 200, so that is a correction that I made when I put things in there. And then when they talk about switch 1 VLAN 1, that's actually switch 2 VLAN 1, which you see again in the table. That comes from subnet C. The first address is 97, the second address is 98. So I have the accurate information in the table now, and now we can move on to actually configuring the lab. So we have our addressing scheme. Step 2 is configure the cable and network as shown in the topology. So let's take a quick look at the topology. It's pretty simple, so we can just put it together pretty quickly. We have 2 routers, 2 switches, and PCs on either side. So I'm going to use 4321s as my routers, and then I'll use 2960s as my switches, and then put some PCs on either end. So let's just get everything in kind of a compact fashion so we can see what's going on. It doesn't look exactly like the table, but if we do this, now one key critical piece here, I will update the labels. That's not the one, this is the one. But we need to, because we're following the lab, we really need to make sure we cable into the right place with each one. So let's work on that now. Let's make this a little bit smaller. So from PC, we're going to change the label on this to PCA to S1. we want a cable going from fast Ethernet up to F06. And then from switch 1 to R1, we need to go from F05 up to G001. And then R1 to R2 is G000 to G000, and let's get that out of the way. We want S2. We go from G001 to F05, and then PCB is where we finish things up. We go from, of course, F018 into Ethernet there. So we have everything plugged in, everything working. Well, everything plugged in at least. Now the next step, attach the devices as shown. Now we need to go into each router. We're going to assign a device name. We're going to disable DNS lookup. I will do this all on one router, and then we'll skip ahead and not worry about the next router. So let's see. We'll start with router 1, CLI, and so we're in here, enable configure terminal, and we want hostname R1, and that is a 1. No IP domain lookup. Enable secret, and they want assign class as the privileged except encrypted password. If we said enable password, that would not be encrypted. So by doing enable secret, that is encrypted, and that is class. Then we want to go into line con 0, and the password is Cisco. And we also want to set login on that to allow login. Now, that is not encrypted. If we do show run and we go through, that is our enable password, that is encrypted. And if we go through to our line con 0, you see password Cisco. It's not encrypted. So we're going to get to that in a second. But first we need to do Cisco as the virtual terminal password. So line, let's do exit and line VTY, and we'll just do, I prefer to do 0 to 15, and password Cisco, log in there as well. Now, this should all be things you've seen before. Do show run, and when we go down here, virtual terminal, we have 0 to 4 and 5 to 15, password Cisco, line con, password Cisco. Now if we do service password encryption, we can now do show run. And when we get down to here, we see password 7. Now this is not a good encryption. This is very easy. You can look online and find ways to break this password, and it breaks instantly. It's reversible. But it keeps anyone who's walking past from looking over your shoulder and seeing what the password is if you're looking at running configuration. That's the purpose of this password encryption. So we did that. We encrypted plain text passwords. Now we want to create a banner to warn people away. So we're going to do banner MOTD, and We can start it with any character we want. I'm going to just say go away. And then we need to end it with the character to tell us to say this is how it ends. Now, if you look at it, if I didn't put the starting character here, it would have thought that the starting character was the G, and it would have kept going because I can do multiple lines on this. So if I wanted to have the pound sign as part of that, what displays? Right now the pound sign will not display. That's the start and the end. If I want that, I need a different starting character. I can't use an exclamation because I have that in there, but I could use, say, a $sign. Now I need a $sign at the end. Now the pound sign is there. I can throw asterisks in if I want as additional. So now this is going to be what gets displayed as my message of the day. The pound sign says this is where it starts, and this, the $sign says this is where it starts, this is where it ends. So I created my message of the day. I can do a copy, run, start. I need to be here. Copy, run, start. And I just copied my my running configuration to startup configuration. Set the clock on the router to today's time and date. And clock set, and today is let's see, we do time. It wants a current time. I'm going to say it is 2 p.m., which is 14. Ooh, and it's incomplete. So now we need the day of the month or month of the year. It will accept either format. So I'm going to start with day. I'm going to say it is the 21st. Now it's going to say month of the year. I'm going to say June. And now it's going to want the year. And I'm going to say, even though I don't want to admit it's 2020, I'm going to say it's 2020. And now we can do a return and we're done. So we set the clock on the router to today's time and date, and we came close enough. Now we need to do that on R2, so I'm going to go ahead and do that on R2, and we're going to come back when it comes to Inter-VLAN routing and configuring the interfaces for R1 and R2. Okay, so we have initial configuration set on both routers. Now it's time to do step 4, configure Inter-VLAN routing on R1. So to do that, we will start by activate interface G001 on the router. That is this interface right here. We'll go to the router, and we want to go configure terminal, and we want interface G001, and we want to do a no shutdown on that. And then we can get out of that. Now we need to go into the sub interfaces. So we're going to start out with G001.100. That's the first, and description is client network. These are where all of the computers are in, well, all of the computers, which is PCA. But now we want encapsulation .1Q, and this is going to be VLAN 100, so we want it to be 100. .1, I don't want a dot there, Q 100. Now we want to give an IP address to that interface, and this is from before 192.168.1.1 and 255.255.255.192. Now we can go to the next interface. I can either exit or I could have gone directly there. Interface is G001.200, I believe. 200. And from here, again, we're going to do the encapsulation .1q 200, and we will give it a description of management network. And here we have the IP address from subnet B that we calculated. IP address 192.168.1.65 and 255.255.255.224. That is our subnet mask. Different from the other subnet mask because we're using variable length subnet masking. Now we can go to our native VLAN. We'll do exit and interface G 0.0/0/.1000, and we can do encapsulation .1q 1000 native, and we'll do a description, call it native VLAN. Now, earlier it said ensure the subinterface for the native VLAN does not have an IP address assigned. So we do a description, and that is it. Now, if we exit out, we should be able to see our show IP int brief. We should be able to see all of our subinterfaces as configured, and let's make the chart look better. We have 001 is up but unassigned. We have, let's give it a little more space. 100 is 192.168.1.1. Subinterface 200 is 192.168.1.65. They are all up, so everything is working there. Now we're going to go into R2, and in R2 we have command line we have interface G001, and we want to give that the first IP address in subnet C that we calculated earlier. We created this in our chart. So configure G001, so we want int G001, and we will do IP address 192.168.1.97 and 255.255.255.240. And we'll do a no shutdown there, and we can exit out. Now we can actually go back and do G000 for both routers. So that's the one that connects the two. And then we'll do routing to tell it to talk back to each other. Now these are addresses that were already in the chart, so I will start with R2 since I'm already there. 00 interface G000, and that is IP address. On R2 it is 10.0.0.2 and 255.255.255.252, and we can do a no shutdown there. And before we do anything else with routing, let's do the same on R1. We have R1 right here. Configure terminal and interface G000, and IP address is, this is 10.0.0.1 255.255.255.252. And we can do no shutdown there also. now they're both up and they can talk to each other. And if I, let's say, exit and we're here and I ping 10.0.0.2, I'm on R1, I get a reply. So repeat it, and I get all 5 replies. So we are able to talk back and forth to the router. Now we need default routes going to each router. So what I want to say is, let's go back into configure terminal. What I want to say is, if R1 receives something and it doesn't know where it's going to go, just send it to R2. Now in the real world, R2 might have a connection to the internet, whatever. In this case, it's just so that if you're trying to get from this network to this network, it's just saying send anything to R2. So what we want to do is on R1, IP route is the 0 network. Oops. 0.0.0.0, 4 of each. If you get anything that doesn't match anything else, send it to 2. And we can do show IP route, and now we have gateway of last resort is 10.0.0.2. So now if we go here, we can exit the interface and do our IP route just back the other way. 0.0.0.0.0.0, 10.0.0.0.1. And now if we want to test this out, we can go to R1 and we can, R1 has no entry for the 192.168.1.96 network. That's subnet C. That's what is here. It has no idea of how to get there. So if we ping it, it should go through that default, that gateway of last resort that we configured. So we'll ping, and that is one of the directions in here. Verify static routing is working by pinging R2's G001 address. That is this address that I'm pointing to right here from R1. Ping 192.168.1.97, and we get a success. So everything's working. Now we will go into the switch configuration. So let's get everything ready to do switch configuration. So we have a switch. I'll go enable configure terminal and assign a device name to each switch. So that's going to be host name S1. All of the same stuff we did on the router. No IP domain lookup. Enable secret class line con 0 is password Cisco login, and then we're going to go into the virtual terminals, line VTY 0 to 15, password Cisco login. And just like with the router, we want to do a service password encryption, and we'll do a banner MOTD. And that is going to be my general message of the day. Go away. And in this case, I won't have the pound signs. I'll use the pound sign as my delimiter. So exit, copy, run, start, and we could set the time. Let's do clock set and 1400, and we will stick with today's date of 21 June 2020. Now we can go in and do the VLANs on switch 1. This is kind of a more important part. So we're going to go back into configure terminal, and we want VLAN 100, and we're going to give it the name of clients, and we need a VLAN 200, and we need to name it management. And we're going to create a VLAN 999 and name it parking lot. Then we'll do VLAN 1000 and name native, and we can exit. Now we're going to go into VLAN 200 and give it that IP address. Now, if you remember back to when we did the variable lane subnet masking, it was actually directing us in the wrong way. It was telling us to use the second address from subnet A, except it should be the second address from subnet B. So we're going to go interface VLAN 200, and IP address is 192.168.1.66, 255.255.255.224. And we can do a no shutdown and exit. And now we need a default gateway for the switch. IP default gateway 192.168.1.65. And then on switch 2, I need to put in the second address from C, from subnet C, and then I'm also going to do all of the basic configuration on switch 2. Won't bother showing you that. So right now, let's actually assign all unused ports. All unused ports to the appropriate VLAN. Actually, it is, we're not there yet. Assign all unused ports on switch 1 to parking lot VLAN, configure them for static access mode, and administratively deactivate them. So basically what we're doing is protecting them multiple ways. Theoretically, if someone plugs in and they can negotiate a trunk port, they can get a lot of information about the switch or a lot of the traffic that's on the switch. So that's why we set it to access mode. We disable them because that means that they can't be used at all, and we put them on a separate VLAN. So even if they get in and they get the port activated and it's an access port, they still can't get anywhere because they're on a parking lot VLAN. So we're going to do interface range and F01 to 4, because remember 5 and 6 we used for the router and the PC. And then we go F04, and if we do a comma, we can do F0/7 to 24. And now remember, there are a couple other ports we have to consider. G0, 1, 2. And now I have all of those ports that I'm configuring at the same time. So I don't have to go into them in separate sections. And I'm setting them to access, and then I'll set them to access VLAN 999, and I'll do a shutdown on them. So they're all down, and then I can exit. And I'll do a comparable thing on switch 2 for the ports that are not being used. So now I can actually go in and look at the ports that I am using. This is step 8. Assign used ports to the appropriate VLAN specified in the table. So I'm going to do interface F06, which is plugged into, it's this cable here plugged into PCA. Switch port, mode, access, switch port, access, VLAN, and this was 100, the client VLAN. And if I exit, show VLAN brief, we can see that we have F06 on 100. We have the rest of them are plugged into, are on 999, which is the parking lot VLAN, and then port 5 is showing up as in the default VLAN, which we haven't made a trunk yet. So that is the next step. Manually configure F05 to as an 8021Q trunk. So we're going to go to configure terminal and interface F05, switch port, mode, trunk, and now switch port, trunk, native VLAN 1000, and then we need to say which VLANs are going to be transferred on there. Allowed VLAN 100, 200, and 1000. And now I can exit, and I could do a copy run start. I think they want me to do that. Save the running configuration to the startup, and I may as well do that. Exit, copy, run, start. So now they say verify trunking status. So let's do show interfaces trunk. And we have port 05 on, native VLAN is 1000. These are the VLANs that are allowed. So everything looks good there. And that covers everything with the switch configuration. I'll do a comparable configuration on switch 2, but then next up is we actually finally do something with DHCP. So we'll talk about DHCP and do a DHCP configuration. Okay, after all of that, it's finally time to start talking about DHCP and actually configure DHCP. So just a little bit of background. This is all in the reading, but DHCP, the way it works is that the client will come online and the client will send out a broadcast. If it's configured as a DHCP client, it'll say, I want to request an address. And there can be one or more DHCP servers that are listening, and they will reply and say, here you go. If they have addresses, here you go. This is an address that you can use. Then the client says, okay, I accept this IPv4 address that you're giving me. And then the server says, I acknowledge it, that you are going to use this address, and here's a little more information if you want it. So that's the general process that happens. In terms of configuration, frequently DHCP is configured on a server that is in an environment. There might be a central server. One of the things to keep in mind is, let's say we're looking at PCA, and in this case we're going to be configuring DHCP on R1, but let's say we had it on R2. PCA sends a broadcast, and what happens to broadcasts at routers? They don't get forwarded. So there's actually a something we'll be doing that will allow just the DHCP request to be forwarded to the DHCP server. And that is something that in the real world you'll be doing all the time. For the most part, depending on your environment, you may be using DHCP in a much smaller environment where it is on a Linksys type device, or a Netgear or some other type of small office router. Technically, you might put it on a Cisco router in a small office. Generally, in larger environments, it'll probably be a Windows or Unix server or Linux server that's running DHCP. So, to get started, in part 2, you will configure and verify DHCP server on R1. DHCPv4 server will include 2 subnets, Subnet A and Subnet C. Okay, so let's go through and do that. I'm in R1 and oops. Oh, and remember my message of the day I created if you were here for the earlier part of the video. So this is going to be console, and let's try that again, class, maybe it was Cisco, and then when we do enable, we'll get another one, and this one is class. So now I'm logged into R1. Exclude the first 5 usable addresses from each address pool. So I'm going to do configure terminal, and I want IP DHCP excluded address. And this works a little bit different from most other DHCP systems. Frequently you will create the scope and then exclude. In this case, you exclude before you even say, here's my pool that I'm going to use. But 168.1.5. So this is the format for excluding the addresses. We will do that. Now we're going to create our DHCP pool. DHCP pool. We're going to call it R1 client underscore LAN. And now we're in our DHCP configuration. We'll give it a network that we're going to use. 192.168.1.0. Now this is the network address, so just be aware of that. 255.255, and we need the 192 subnet. So this is the network address. Our router address, the interface address was .1, but the network address is .0. We'll give it a domain name, so this gets applied because they say configure a domain name CCNA lab. This gets applied to the computer. This is some of that additional information. Lab.com. We want to give it a default router. That is the default gateway, 192.168.1.1. Now this is a critical piece. Without this, it won't the client will not be able to communicate with anything off of the network. Configure lease time for 2 days, 12 hours, and 30 minutes. Lease 2/12/30 is the format. And this is just this is a strange lease duration. It is purely to show you that the timing is there. But what happens with the lease duration, that's how long the lease is valid. What will happen is that 50% of the lease time, the client will try to renew the lease, and it'll go through a process over the next 50% if it can't renew. So we're still in configuration. It is not allowing a lease configuration. Why is that? What am I doing wrong? Okay, so the lease duration, they are telling us to set it, but it doesn't look like it's working within Packet Tracer, so I'm going to skip over that piece. Just to know, the lease duration is the amount of time that the IP address can be used by the client. At the end of the lease, it has to stop using it. At 50% of the lease, it'll try to renew it, and it'll go through that process again. Now, next configure the second DHCPv4 pool using R2 client LAN and the calculated network. So let's just repeat the process, even though it is duplicating what we did before. We can exit this configuration, IP DHCP DHCP exclude address is 192.168.1.97, and they said the first 5, so 192.168.1.101, and that's what we're excluding. Now we want to create our pool, IP DHCP pool, and this is R2 underscore client LAN. And then the network here is 192.168.1.96, and that is 255.255.255.240. And the default router on this one is the 97 address, 1.97, and domain name CCNA lab.com. And once again, we will skip the lease duration. Exit, copy, run, start. They say save the running configuration. Now we're going to look at the pool details. Show IP DHCP pool. And we have R1 pool, 62 addresses, no leased addresses, 2 excluded addresses. That's strange. So now we're going to see if we have any bindings. That is show IP DHCP bindings. And we have nothing there. So now we're going to try to acquire an address from PCA. So we're going to go to PCA and a command prompt. And issue the command ipconfig. And before we go there, if we go to the IP configuration, actually, it wouldn't have worked. We need to set it to DHCP. And it's requesting an address and it got one. So if command prompt, if we did ipconfig renew, it wouldn't have worked because we were not set for DHCP. We are now. We can do a renew and reset that. But now from here, let's close this. Not terminal, command prompt. I can try to ping R1's G001 IP address, which is 192.168.1.1, I believe, and I'm getting a reply. Now, if I try to ping 1.97, that should work as well, because that's just getting to a different router. If I can get to my network, if I can get to my default gateway, then I should be able to get out. So that works. Now, if I go to PCB, I have a DHCP pool here, but it's not going to work yet. And that's where we get into part 3. Just to show you, if I go here and IP configuration, it will eventually time out. Yeah, it's DHCP failed, a PIPA is being used, 169 address. So now we're up to part 3, configure and verify a DHCP relay on R2. So what do? We go into R2 and we say Cisco enable class configure terminal. So we want to go into our interface that it's listening on, and that is G0001. And this is saying this interface right here. So what do we want to do with that? We want to say IP helper address. This is saying if we need IP services like DHCP, send that to 10.0.0.1. That's R1. That's this interface on R1. So if someone requests an IP address, send it over to R1. So if we do that, we can now exit and do a copy run start, just because they told us to. So now we'll go back to PCB, and if we look here, IP configuration, it already picked up an IP address. And remember, we had an exclusion of 1.97 through 1.101, so it picks up 102. Now if we go to R1, we can look at DHCP binding and server statistics again. So DHCP binding, now we have two systems here. Before, when we ran it, we had no systems. We have two systems. We have the MAC address, we have information about it. So one final piece from here, obviously I was able to ping my router. They didn't tell me to, but I pinged the other router. Now what if I wanted to ping the other PC? We saw it was 102 and we're on PCA now. So will we get all the way across and back? And there we go. Once we time out to finish up ARP requests, we can now ping from PCA to PCB, and we should be able to ping the other way. So, a lot going on in this lab that's well beyond DHCP. But you can see that the DHCP configuration, pretty straightforward. And if you looked at it from your home router perspective, you would see that it's also pretty straightforward, easy to do. Windows, Linux, it is all a similar process. So the key piece, and the key piece that you will see in any environment, IP helper address. Without that, you won't be able to forward DHCP requests from PCB over to R1. So with that, that's all I have for you today. Thanks for watching.